Okay. Welcome everyone to the June Lunch and Learn. So today's Lunch and Learn, the topic, it sounds very chemistry, and it kind of is, but we'll go through it together, don't worry. This Lunch and Learn topic came as a request, and I think it's actually a great one because I think it's words that you probably see as maybe you're picking yeast strains, or you pick up a textbook or see something online about wine aromas. And hopefully I'll be able to put it into perspective so that when you see these words, ooh, hold on, I just got a thing popping up on my screen here and I've got to move it. And I cannot move it. Here we go. Okay. Okay. So, ooh, sorry. So hopefully, yeah, I'll go through this, and that way when you see these words in you know, catalogs or whatever, you'll just have a little bit more background and perspective about what they're talking about, and if you want esters and thiols in your wine. So let's jump into this. Esters and thiols are aromatic compounds. They're volatile compounds that we can smell. So that's where we're going to start. Is to remind you, how do we smell, and the difference between aroma and flavor, because I think this is really important to remind ourselves of. The difference between aroma and flavor. So aroma is smell. Okay. It's there's a couple different types of perception. There's orthonasal, which is right up the nose, retronasal, which is up the back of your mouth, and into the nasal cavity. And so those are both aroma. Flavor is a combination of it's when something is in your mouth, a food, a beverage is in your mouth, and you have your taste, your retronasal aroma, aroma, and tactile sensation. So, is it hot? Is it cold? What is the texture? What does it feel like? Those three together make up flavor. So flavor, and I'll be honest, I think this is important to note because I used to always say flavor is retronasal aroma. That's how we get flavor. No, flavor is the combination of those three things. Okay. So it's important to note that because you need all three if you're talking about flavor. Okay. So it's the sum of the characteristics of the material which produces those sensations. So just keep that in mind. We're going to be talking about aroma compounds today, and those aroma compounds, they must be volatile to get into your nose, to interact with your epithelium, the yellow hairy structure that you see in that picture. They have to be in the gas phase to get up there. And so that's why we swirl our wine. That's why maybe before we produce our wine, we want to be gentle with it because we don't want to volatilize those aromas. We want them to stay in the solution. So yeah, just keep that in mind that they are volatile. So when you are making your wine, they're wanting to get out. And so there are things we can do to make sure that they don't get out so that they can be enjoyed by, your consumer. So just keep those in mind. Orthonasal, again, right up the nose. Retronasal is that up the back of the mouth, and interacts with all the same cilia and the epithelium. Okay, so let's move on. The volatile compounds that are in wine. So what things are in that form that we can actually smell. So in wine, we consider that there's three classes of volatile compounds: primary, secondary, and tertiary aromas. Primary aromas are ones that are present in the grapes and they persist after winemaking. And so they are, you could open the grape up when it's ripe and or put, you know, put it in your mouth, chew it around, and that's what you can smell or taste, or sorry, flavor, let's say. They give some of those varietal characteristics. Secondary aromas are probably the most important and the largest class. So these are generated during the fermentation by yeast or bacteria. So the largest group, both qualitatively in terms of they have the biggest impact on the wines that you are tasting, and quantitatively. And it's important to remember a lot of the secondary aromas are generated from things that are in the grapes. They're generated from precursors that are in the grapes. So a lot of people, I think, call those uh, primary aromas because they only are present because of the things that were in the grapes, but they were generated by the yeast, most likely the yeast. But some bacteria have effect as well, especially if you're doing like a malolactic fermentation. They will produce some aromas as well. The tertiary aromas are aromas that are generated during maturation or aging. So some of the secondary aromas that we're going to talk about, the esters, they can also be, some of them can be considered tertiary aromas because they might actually be formed during aging. And then when we talk about aging or maturation, what are we talking about? In oak, you know, if you're aging your wine in oak, or if you're aging your wine in Sur Lie, let's say, you keep all the yeast in there. That is can have an impact on aroma. Or in the bottle after you bottle it, if aroma compounds are created or and then that is considered a tertiary aroma. So sometimes you can have the same aroma be a secondary aroma or a tertiary aroma, and you can't tell the difference. It's just that they could be created during the fermentation or they could be created in the bottle. So if we were to, analyze them here in the lab, we can't necessarily tell when they were created, but we could see the quantities of a lot of these compounds. Okay, so primary, secondary, tertiary. So there's lots of chemical classes of volatile compounds in wine. This is a list here, and this is if anybody took organic chemistry in maybe at the end of high school, but probably into university. These are some of the classes of compounds you would have studied how to name them. The only two we're going to look at today are the esters and some of the sulfur compounds. We're going to leave the rest for another day. But these are two actually really important classes. Another one that I just want to point out, the terpenes. That's one that Randall Voss and I do some research on looking at La Crescent. And the terpenes are a really important primary aroma in some grapes. And yeah, it's one that we're looking at with La Crescent. An interesting fact, Frontenac Blanc doesn't really have any terpenes in it. So La Crescent is high in terpenes, which are tropical flavors and floral. And Frontenac Blanc, on the other side, doesn't actually have hardly any terpenes at all. And so when we're looking at our Frontenac Blanc work, we're looking at different classes of compounds. Okay, so let's jump in. We're going to start looking at esters and what are esters that are important in wine, and how can we try and enhance them in our wine. So the definition of an ester, and again, this is where it's going to get a little chemistry, but just bear with me because we will bring it back into wine and how that's important. So ester molecules, they're organic compounds. They're represented by this general formula. And important to note that it's a reaction between an alcohol and a carboxylic acid. So an alcohol and an acid get together, have a reaction called an esterification reaction. And that happens by the yeast. The yeast do these esterification reactions. And typically we get these fruity smelling aromas in our wine. So typically esters are secondary aromas. Sometimes they could be tertiary aromas. So a lot of times the yeast have a lot to do with this, but you can get these reactions happening spontaneously in the bottle. So there's lots of different carboxylic acids and alcohols in wine. And a lot of them come from the grapes themselves. They're in the flesh of the grapes, and they are from different metabolic processes that the grapes are performing during their lifetime. So, so yeah, there's lots that are available, and so they can react together, and we can have, about 160 esters have been identified in different wines and in different cultivars. So different, higher levels of certain alcohols or certain acids, and so there's might be more, some that are more prominent in some cultivars than others, or wines, I should say. These esters will typically increase as wine ages because you can, again, if there's acids and alcohols sitting around, it's very thermodynamically favorable to create esters. They're nice and stable. And in terms of chemistry, that's the way the chemistry wants to go. And water is, so this is an example of an esterification or an ester condensation reaction. And you get your ester at the end after your carboxylic acid and your alcohol react. And you also produce water. So that's also favorable in terms of the thermodynamics. Now, there's lots of different esters out there. So how do they get named? Just a quick naming convention. The carboxylic acid portion is the end of the name. So the hexanoate comes from hexanoic acid. And then the section that's attached to the alcohol here on this side is the beginning. So ethyl, and then hexanoate is on the carboxylic acid side. So again, just a reminder if you took some extra organic chemistry, and just if you haven't, at least it gives you a start as to where the heck some of these names came from. Okay, so let's talk about what are some of the common ones that we have in wine, and what they look like, what they smell like, and yeah, let's jump into that. So this is just a quick little diagram of some of the ones that are common in wine. Ethyl acetate, now not necessarily our favorite ester, but it is an ester, and I will point out a couple other things about ethyl acetate in a minute here. Isoamyl acetate is an important one in young wines. And so the yeast produce a lot of this and release a lot of this at the beginning of or during a fermentation, and it's in wines at the beginning of their life. I do think that this dissipates over time, probably due to some other reactions that could happen. But banana is really common if you drink Beaujolais Nouveau, which is a wine that is harvested in probably September and then released in bottle by November. So very quick turnaround. A lot of those wines have a bit of a banana flavor to them. So some of the other acetate esters. So again, the acetate is just telling you that there's two carbons on this side, on the left-hand side here. So phenylethyl acetate is a very important one. Rose, honey. So there is quite a bit of phenylethyl acetate in the wines that we make, with the white, more so the white varieties that we have here in the Midwest. Isobutyl acetate, as you can see, can take on a lot of different perceptions. And one thing to note with these esters is that when you have more than one, you may not pick out exactly rose or exactly banana, but once you start to have more than one, two, three esters in combination together, you can get a variety of different perceptions when you smell this. So they tend to have an effect on the overall perception when there's more than one. So on the flip side, There is the ethyl esters. So these are the acetate, some of the acetate ones up here. If the ethyl is on the other side as the alcohol, you might think that that is common in wine because the ethanol that is present can lead to a lot of esters. So there's quite a few ethyl esters that are present in wine. A couple of the more common ones, ethyl caproate and ethyl caprylate. The only difference here is how many carbons it's got on its backbone. One of these is actually ethyl hexanoate that I showed you on the previous slide. This is a common name that, unfortunately, in chemistry, before conventions were put in place, people gave common name, people gave names to things, and so we're still using some of those today. But go back and maybe if you want, when we post this as our video, you can see which one of these is ethyl hexanoate. But anyway, this smells like apple peel. And so again, lots of these esters, I'm going to jump to the next slide. Lots of these esters, especially these small esters, are fruity. That's kind of the generalization, is that esters give you fruitiness in your wine. And some of them don't have very specific notes or very specific fruits that they're associated with. It's just fruity overall. But it is possible some of them are tropical: banana, pineapple, apple, pear. As the backbone of some of these esters get larger, you can get more soapy, oily, waxy notes. So again, if those precursors are present, and that's going to probably be a little bit more cultivar dependent, you could see less fruitiness and maybe more soapy, oily, waxy notes. And not necessarily in a bad way, okay? But just keep that in mind. The fruitiness will be dissipated. This could also happen over time. Okay, you might get less fruitiness. Those esters may diminish a little bit, and you might see some of the larger esters. There's a positive effect of multiple esters together, providing this overall fruity aroma. So again, if you had ones that are more banana individually and pineapple, maybe together, they're just giving an overall fruitiness. So overall, the esters are interesting because they actually, when we measure them in the lab, they have high concentrations. We can easily see them on some of our analytical instruments, but they also have higher thresholds for you to be able to smell them. So they may have the same kind of aroma intensity as, we're going to talk about thiols in a minute. So when we are analyzing them, we might see a much higher concentration of esters, but in terms of the aroma perception, it may be on par with some of those thiols that are in really, really low concentration. So if you're talking about esters or you're reading about them in a book, you might see them listed as ppm, parts per million, which another way to think of that unit is milligrams per liter. Versus a lot of the other aroma compounds that you may see in the thiols, although the thiols could probably go even lower than this, but are usually listed in ppb, so parts per billion, which is micrograms per liter. So just to keep in mind, there's lots of esters in wine. They do contribute that fruity aroma, but they are in higher concentration. So the last thing I wanted to talk about esters was this ethyl acetate, because it's an ester. It's definitely present in all of our wines, and it can be problematic. So if ethyl acetate gets into concentrations that are too high, we have a faulted wine, essentially. So at low levels, 30 to 60 ppm, parts per million, or milligrams per liter, at low levels, it contributes to the overall fruitiness. So there's no problem with small amounts of ethyl acetate, and that's totally normal during a fermentation. At higher levels, it does add what I call a solvent aroma. A lot of people say nail polish remover. That is true. The acetone-free nail polish removers tend to be ethyl acetate. Also nail polish in general. So if it starts to smell like, a permanent marker or nail polish remover starts to smell like solvent, chances are you may have ethyl acetate at a higher concentration. Now keep in mind, acetic acid and ethyl acetate are closely related. If you can smell ethyl acetate in a negative way at 150 to 200 ppm, in contrast, acetic acid you can't smell. It's not even necessarily in a negative way at this point, but you really can't smell it until 800 ppm. So much different threshold there. We can smell ethyl acetate at much lower concentrations, and so any increase in ethyl acetate can be problematic. It is produced by yeast during fermentation. Some ways that you can control the formation of these esters overall, but also ethyl acetate, is through temperature, nitrogen, SO2 level. There's spoilage yeast and bacteria that will definitely produce ethyl acetate in higher concentration. So another plug for, proper SO2 management and proper management of your wines really post fermentation. So then how do we, actually one more thing about esters, how do we enhance them in our wine? They're fruity. That's a good thing. We want those fruit flavors. So grape maturity. So a higher maturity level of your grapes can lead to a higher ethyl ester formation. So that was that apple peel. You might get lower acetate ester formation. So again, you might want to look into which esters am I going for? And I'll put a plug in now. Randall Voss and I are gonna be presenting some of the Frontenac Blanc work at our meetup that we're having on June 18th. And we are looking mostly at esters in Frontenac Blanc. And so hopefully we'll be able to see a difference there of some of the earlier harvested grapes versus the later harvest grapes. Yeast strain can play a big role, and I will talk about yeast strain a little bit towards the end. But yeast strain, it's really easy to take your yeast catalog, either online or if you've got a print version, and you're going to see the word esters and thiols listed over and over and over again. And there are yeast that are high ester producers. So again, if that's what you're going for, you can use those yeast strains. But in conjunction with that, temperature, so a lower fermentation temperature favors ethyl ester formation. And this is all from research. And it's also going to help keep those aromas in your wine at a lower temperature so they don't escape. Fermentation nitrogen, so making sure that you have good fermentation nitrogen, but also an ammonium salt addition before fermentation. So a lot of times we're adding our ammonium salt later on, maybe at the 1/3 decrease of sugar mark. But an ammonium salt addition before fermentation enhances ester production. So something to keep in mind. Most people are just using maybe Fermaid K or Go Firm, I should say, at the beginning of a fermentation, but maybe adding your nitrogen up front could be a good thing to try. And maturation, so increase in higher molecular weight esters, so the big, longer esters, which may give you, like I said, those more waxy, oily type of aromas, happens during maturation. And so another point is low SO2 can also favor ester formation. Not what I would necessarily recommend. I would try the other things first, but just an FYI that if you have low SO2, you may see changes to your wine as after they're in bottle. Okay, let's jump over to thiols, and then we can go back and chat about all these things. So what is a thiol? A thiol is it's a sulfur-containing compound. A lot of times that freaks people out. A lot of the sulfur-containing compounds we do not want in our wine because they do not smell very good. But there are several sulfur-containing compounds, thiols in particular, um, that are good and that do smell good, and we do want them in our wine if possible. So this SH group is it's analogous to an OH group on an alcohol, and it's a thiol group, or it could be called a sulfhydryl group. So if you might see that in some publications. Traditionally, thiols are referred to as mercaptans. I think mercaptans has kind of a negative connotation as to a bad smelly compound. So I think most wine professionals use thiols when they're use the word thiols when they're talking about good thiols, good sulfur containing compounds. They have very, very low threshold levels. It is very difficult for us to be able to pick these up on our analytical instruments. So we can smell them. We have an instrument where we can separate things, and then we can smell what's coming after the separation, the individual compounds, and then we can also see it on a instrument that tells us the identity, the mass spec, and we can smell those things, but there's no peak, there's no signal, because the concentration is just so low. So, so it's a bit of a challenge, but at least with that olfactometer, we can tell it's there. A lot of these thiols or mercaptans are considered faults. So hydrogen sulfide is is usually where things start. Methane thiol, ethane thiol, 2-mercaptoethanol. These are not things we want in our wine. Rotten cabbage, onion, burnt rubber. So these are the thiols we are trying to avoid. I will say it's the sulfur compounds in wine do tend to come from an amino acid that contains sulfur. So sometimes it can be difficult to control. If you want these good sulfur compounds, I would definitely recommend using the yeast that promote them. So what are those good sulfur containing compounds? Some of the good thiols, and there's a couple more than this, but these three are the most common ones. And you can see this first one is actually an alcohol with a thiol group attached. This one is an ester, okay, with a thiol group attached. And this one's actually a ketone with a thiol group attached. So the naming convention is that this is an alcohol. This one is an acetate, which is an ester, and this one is an pentanone, which is a ketone. But they do all have the mercapto in the naming convention. So people have given these short forms because nobody wants to remember these names: 3MH, 3MHA, 3MMP, which, to be honest, I don't think the short forms are that much easier, but these are the good thiols. They all have a very similar aroma. Passion fruit, grapefruit, gooseberry, guava, box hedge. I'll be honest, grapefruit's probably the only one I know what it actually smells like. So if this is, some inspiration to go and try and find these other flavors, and aromas, go for it. I would, maybe it'd be easier to find some of these in, body washes or cream, hand lotions or things like that, than it might be to actually find the fruits, here in the Midwest. But maybe you already know what some of these things smell like. But to me, it's it's a tropical, sometimes more herbal, and green, like the box hedge, or cat pee sometimes gets used as a reference, just if you see that. But yeah, these are the good thiols. We talk about these thiols a lot when we talk about Sauvignon Blanc. And we don't grow Sauvignon Blanc in the Midwest. But we're growing a couple of varieties now, or that have just, come on the scene, let's say, that have been referred to as being Sauvignon Blanc like a lot of times. So things like Itasca or Clair, I keep hearing them being compared to Sauvignon Blanc. So I'll be honest, we haven't done research into if these particular compounds are present. Maybe that's something we should do so that should we be going after these thiols? Are they present? Should we use yeast that can go after these? So, because if the precursors are not present, it may be a waste of time of using some of those yeast. Maybe not. Maybe there's other good reasons to use some of them. But just keep that in mind that we haven't quite confirmed that some of these thiols are in the grape varieties that we grow. So how do we enhance thiols in wine? Well, the first thing I want to say is let's talk about prevention. Let's talk about prevention of those of the stinky, smelly thiols, mercaptans that we don't want in our wine. So to prevent the faults that a lot of sulfur compounds can bring, we really need to make sure we have enough available nitrogen for the yeast. You want to have clean fermentations. The yeast need building blocks to make proteins and things like that in their cells for when they divide. And so you need to have enough nitrogen. You can have too much nitrogen. All right. So you don't want to go overboard. Nitrogen is something, yeast assimilable nitrogen is something we can measure here at the lab. I don't think you need to do every cultivar, everything in your vineyard, probably measuring a couple of, one or two white varieties, one or two red varieties, and seeing where you're at. It can give you an idea of where your vineyard is at overall. So, yeah, I would highly recommend getting an idea of where your nitrogen is before your fermentations. Yeast selection also, there's different yeast strains require different levels of nitrogen. So if you're using one that has a high nitrogen requirement, be aware of that. You may need to bump that up a little bit. Also, apple, if you're doing apple cider, apples are notoriously very, very low in nitrogen, and you need to feed those yeast with appropriate nitrogen sources. So if you're making apple cider, keep that in mind. Juice settling can help to get rid of things that yeast can convert into nasty and prevent the yeast from getting stuck in doing stuck on those particles and get them in the wine and fermenting the sugar the way that you want. Use of SO2, so you may want to bring down the populations of wild yeast or any spoilage yeast that may be kicking around in your winery. So using SO2 during that juice settling may be a positive thing to prevent spoilage yeast from creating any of these mercapto type compounds. For the desirable thiols, I would say your yeast strain is going to be very, very important. So the precursors are present in the grape flesh, and then the yeast convert those to the thiols. And so these are some that I was looking in the Scott Labs book, and they actually, I will point out the grassy thiol yeast or tropical thiol yeast. This is on the white wine fermentation page. It's not on the hybrid page. There is a whole, there are thiol recommendations for yeast on the hybrid page. I went strictly for the white wine fermentation. It's mostly the same information. I just wanted to let you know where I got this information from. So there's lots of yeast out there that are possible to use. I would read, if any of these sound interesting to you, read the rest of the description and make sure it makes sense for your fermentation, for your cultivar, and because this is not the only thing they're going to produce is thiols. All right. So make sure that makes sense for your operation. And then the other thing I wanted to point out, there are yeasts that are specifically for esters and thiols. They do both. So if they're both if you're interested in as many tropical fruity aromas as possible, here is a list, again, from the white wine fermentation page, not from the hybrid page, of ones that are listed as yeasts for esters and thiols. So they just have the molecular machinery to do this, to do what you want in terms of the esterification reactions and then also that thiol conversion. And then there is a specific list for hybrid whites and reds. So if you have specific cultivars in mind, check that out and see if it's recommended to use any of these yeasts. I highly recommend, I know it's not always easy because you've got wine to make and bottle and sell and all the rest, but bench trials are a really great idea. And the other thing I would say is be wary of yearly variation. You may use or have used a yeast, let's say last year. We were in a drought last year. It was also kind of a weird harvest, right? With the hot temperature and the hot, dry temperatures. And something might have worked really, really well. You might be happy with it, and that's awesome. If you use it again this year, you may have a different result. I'm not going to say it's bad. Maybe it's perfectly fine and you're happy with it. But you may get a different result. Now, again, maybe this year will end up drying up and it'll be very similar. I don't know, but I'm just saying there are year-to-year variation on the grapes. So what your yeast have as their starting materials may vary. So I know lots of wineries get really excited and get kind of stuck with certain yeasts, and they really like those yeasts and they're going to continue to use those yeasts. But just be aware that you could get different results in different years. And maybe that's okay. Maybe that's exactly what you're going for. If you're going for consistency, just be aware of that. You may get different results year to year. Okay, so just to wrap everything up, esters and thiols are mainly secondary aromas, so mainly produced by yeast during the fermentation. And they come from precursors in the varieties, in the cultivar, different grape cultivars. And then which yeast strain you're using also plays a large role if they are present in your wine. And so esters are generally fruity. That's the overall consensus. Exactly what fruit they are perceived as can be very specific. Like isoamyl acetate is banana all the way, but they can be just labeled as overall general fruitiness as well. They are in higher concentrations because they have higher and they have higher thresholds. So so just to be aware of that, you're going to see esters in milligram per liter concentrations, whereas the thiols, you're definitely going to see those in micrograms, if not nanograms per liter. So thiols, many of them are false. Some of the larger, more complex ones are more pleasant. Those fruity, citrus, guava, those kinds of, sometimes a little bit herbal. They can be present in very low concentrations, but still since they have low thresholds, they can be impactful, very impactful in your wine. And you can enhance esters and thiols with fermentation choices. So yes, read the manufacturer's recommendation for the different yeast strains, but also consider keeping your temperature lower, making sure that you have good nitrogen in your juice so that you'll have a nice clean fermentation. So do your yeast a favor and help them out as well. Okay, so that is what I have to say about esters and thiols.